The set point for the PID process is in parameter 911. We've been manually entering that from the keypad in all of the videos in this series. But the cool thing about the WEG CFW series of drives is that the set point can come from lots of different places. Parameter 920 controls where the set point comes from. It can come from the HMI like we've been doing. It can come from an external device via one of the communications modules. Maybe you have a PLC talking to the drive via Modbus RTU. The PLC just writes to parameter 911's address to set the new set point. Check out the WEG VFD Modbus RTU videos if you want to learn how to communicate with a WEG VFD via Modbus RTU. The set point can come from an analog input. Maybe you have a drive running a process and you want a second drive to follow that process. Or maybe you just want to connect a potentiometer so you can dial up whatever set point you want. Let's do an analog set point example using a potentiometer. The CFW-300 variable frequency drive has one analog input on the base drive, but we're using that for our process variable, so I added an analog option module to give us a second analog input for our set point potentiometer. You can use any analog input module you want. I chose this one because it was the least expensive. I wired it like this. I love that the WEG CFW-300 drive provides the 10-volt reference I need for the pot. Okay, let's fire this thing up and go view parameter 27, which tells us if we installed the module correctly. Yep, I see a 1, which is this I/O module. I got that from the drive's programming manual parameter listings. Now if you see a 0 here, then something's wrong. Go take a look and make sure those pins didn't get bent. You can also see the software version of that module in parameter 24. Given that the module is recognized by the drive, let's go to parameter 236 and set it to a 16 to tell analog input 2 it'll be used as a set point. Now we can go to parameter 19 to verify that the drive sees the raw analog input. Looks like we can go from 0 to 97.7%. That's good enough for this demo, but if we wanted to, we could tweak the gain of the analog input to get the full 100%. I'll put this back near the center of the range. Let's go to parameter 920 to tell the PID application to retrieve the set point from analog input 2. Now if we go to parameter 911 to view the set point in engineering units, we can verify that the PID application sees the set point and it's at 6.49 psi. We can vary that over the range, and let's start out right at 6 psi. Switch to run. And sure enough, the PID application adjusts the motor speed to get the system to 6 psi. I'll put the set point at 5.5 psi. But look, the actual system psi is only 5.35 psi. Why is that? Well, it's because we optimized our system for 6 psi, and since our system isn't linear, the farther away we get from the 6 psi, the greater the deviation will be. Now that's no big deal, because we can simply rotate the potentiometer to get whatever system psi we want. I'll take it back to 6 psi, and sure enough the system levels off right at 6 psi. The set point can also come from the WEG drive's built-in electronic potentiometer feature. Digital inputs 3 and 4 are used to increment and decrement the set point with switch closures, like you would see on a modern electronic appliance where you press an up arrow or down arrow to change something. I'm using this joystick, which is really controlling 2 switch closures. One closes when I push up on the joystick, and one closes when I push down. You can use any kind of switch closures you want. I chose this one because I had it laying around, and it was something a little bit different. Let's go to parameter 12, which tells us the status of the digital inputs. Push the joystick up, and yep, the 3rd bit lights up, giving us a 6. And if I push the stick down, the 4th bit goes active, which gives us a hexadecimal A. Perfect. We now know we wired it correctly. Parameter 265 is where we tell the digital input 3 he'll increment the potentiometer, and parameter 266 is where we tell the digital input 4 he'll decrement the electronic potentiometer. Of course, we need to go to parameter 920 and tell the PID application to use the electronic potentiometer for the set point. If we go to parameter 911, we see that the electronic potentiometer defaults to the minimum process variable value that we put in parameter 922. I'll hold the joystick up to scroll to 6 psi. Toggling the joystick just increments or decrements the value one at a time. Looks like everything's working, so let's switch to run, and the PID application automatically adjusts the motor speed to get us to 6 psi. And of course I can change the set point using the joystick to increment or decrement the electronic potentiometer. And again, if I just toggle the joystick, the set point just increments 1 digit at a time. Finally, you can have up to 4 predefined set points, which you select using digital inputs 3 and 4. The wiring is exactly the same as the electronic potentiometer we just did, but this time I'll use discrete switches to enable each bit. Let's go back to parameter 12 to view the digital input status again. This time, I'll disable the auto manual switch so it's easier to read the results. Sure enough, this switch controls digital input 3, and this switch controls digital input 4. Perfect. Looks like I wired it correctly. I'll turn both switches back off and enable auto mode so PID automatically controls the motor when we switch to run. Let's go to parameter 265 to tell digital input 3 he'll be the least significant bit of our selector, and parameter 266 to tell digital input 4 he'll be the most significant bit of the selector. And let's go back to parameter 920 to tell the PID application to use digital inputs 3 and 4 to select the set point values from a table. Now we'll go to parameter 912 to enter the first set point. How about we make that 5 psi? Parameter 913 is the second value. We'll make that 5.5 psi. Parameter 914 is the third value, so we'll make that our usual 6 psi. And parameter 915 is the fourth value, so we'll set that to 6.5 psi. Okay, let's go back to parameter 911 where we can see the set point value. Both switches are off, and sure enough, we get the 5 psi we put in that first table entry. Turn on digital input 3, and we get the second value in the table. Turn that off and turn on digital input 4, and we get the third value in the table. And turn them all on, and we get the last value in the table. Perfect. Well, let's go back to 6 psi and switch to run. And of course, the PID application takes the system to 6 psi. I'll turn both switches off to get 5 psi, but the system goes to 4.7 psi. Why? Well, again, we optimized PID to work at 6 psi. But because our system is nonlinear, the farther away from 6 psi we get, the less accurate it'll be. We could go back and optimize the system using the techniques in this video, but it's a whole lot easier to just tweak the set point values in the table. So let's go to the first entry and modify it until we get 5 psi in our real system. Great. Let's turn on digital input 3, and as the system settles out at the new set point, we see it's off a little bit too. So I'll just go to the next table entry and tweak that to get the actual system pressure to 5.5 psi. Of course, if we enable digital input 4 only, we get our 6 psi. And if we enable both digital inputs, we see that the system doesn't settle out at 6.5 psi, so I'll go to that table entry and tweak it a bit until we get 6.5 psi. So now we can quickly dial in 5 psi, 5.5 psi, 6 psi, and 6.5 psi. And let's finish up back at 6 psi. Now, of course, this would normally be controlled by a PLC or some other controller. We're just using the switches here for demo purposes. Now, one side note. All of this assumes you have the PID app running. You should see a 1 in parameter 903, which says you're using the PID application and not a user application. And you should see a 4 in parameter 900, which says the PID application is running. If it isn't running, then go to parameter 901 and set it to a 1. You now know several ways to control the set point on a WEG Variable Frequency Drive. Click here to see all of the videos in this series. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos, and click here to learn about Automation Direct's free award-winning support options.